hizi napanda. Unasongesha aje hiyo slide? Eh? Hello, good morning. Good morning class. My name is Kibet Ngeno. I'm taking you through this unit of organic chemistry. And one of the organic compounds that you want to look at is the benzene. Therefore, we are going to learn about this benzene in terms of structure, and I expect at the end of the day, at least we shall have known how we how the chemical reactions of the benzene and the structure itself. So let us learn about benzene from the history background, that how this benzene emerged. So as we can see, benzene was first discovered by somebody called Michael Faraday in 1985. He discovered this compound from a fish, that is a mammal that is in the sea, called whale oil. From the whale itself, the fish. So when he extracted the whale oil, he realized that this oil have some organic compounds, and the organic compound itself that has an empirical formula of CH2, that is the hydrogen, 2 hydrogen molecules and one carbon molecule. So the correct molecular formula was established in 1834 by another scientist, which he synthesized and was given a formula of C6 hydrogen 6, and the formula had a lot of contradiction. Therefore, there are several structures that emerge, that which was very difficult to establish which was the real structure of the benzene. So anyway, before we go there, we can look at that benzene itself is aromatic, in the sense that it has some aroma, it has some appealing sense, and there were several structures that emerge from the benzene itself, like the naphthalene, we have the anthracene, we have the phenanthrene, and several others. But basically, this benzene has a high hydrogens to carbon ratio obtained from the degradation of these fats that I have mentioned from the whale itself. As we proceed, the structure of this benzene, there was I've said there was a lot of contradiction. So he had a structure called Kekule structure, we have the Diwa structure, and we have the aliphatic itself that has an open chain that was not fused at first, but finally when it was fused, it gives us a 6-membered ring, that is something like a cycle, but it's not merely a cycle, but it has electrons which was moving and which was delocalized inside it. So therefore, at the course of this establishing the actual structure of benzene, the following observations were made. There were some observations that were made, and the first one was benzene has one monosubstitute isomer. That is, when we say it has a monomer, there was if there was any other element that may come in and maybe attached to the benzene, it gives us an isomer one at a time. So meaning these isomers can be the chlorine, can be the bromine, can be the iodine or the nitrites itself, which give us the argument that eliminates the structures that are indicated in the whiteboard, that the structure 3 and 5 was eliminated. 3 and 5 was eliminated. So benzene yield, the second one is benzene yield only 3 distributed isomers, that is the 6 hydrogen, 6 carbon, and 4 hydrogen, and which in the sense that the structure 4 of the diene is eliminated because it could give 2 isomers. So structure 2, that is the diol, was eliminated because it could give 6 structures. So as you can see, from the structure itself, this benzene ring can attach to several isomers thereafter, but depending on the position. So it can be on position 1, 2, or 1, 3, or 1, 4. So from the argument, only the Kekule structure remained. So this guy called this guy who decided to give a good structure itself also visualized that benzene has a dynamic structure where the double bonds are delocalized. That means the electrons, the pi electrons are not delocalized inside the ring. So therefore, so the carbon-carbon bond in benzene is an hybrid of a single and a double bond. As we let us see the characteristics of this benzene anyway in shortly before we end our lesson. So benzene, it has been established that it has very different properties from closely related molecules. That is a comparison of benzene with cyclohexene and cyclohexadiene is made. The structure itself is this one that I have written in the whiteboard, so you can see the difference. That is the movement of the delocalized electrons inside the ring. So the alkene undergoes electrophilic addition reactions with hydrogen, with the chlorine, bromine, and iodine, as I have mentioned before. So benzene, on the other hand, prefers to undergo electrophilic substitution reaction. As you can look at from this table that if there is a reagent like the potassium iodide, which is cold and dilute, if we can see from the cyclohexene or cyclohexadiene, there is a rapid decolorization, but in benzene there is no reactions. So if we add also benzene there is also a rapid decolorization, and while in benzene there is no reaction. If you use hydrogen bromide, hydrogen iodide, the rapid addition reactions in cyclohexene happens, but when it is in benzene there is no reaction. Let's say now if we are using now hydrogen in presence of nickel, there is a rapid reactions at 25 degrees Celsius and low pressures in cyclohexene, but in benzene there is no reaction but slow reaction at high temperatures and pressures. So if we see the orbital pictures of the benzene, all carbon atoms of benzene are sp2 hybridized. This one you have come across in organic chemistry, how you have arranged the electronic configuration. So therefore, the benzene itself is a diagonal planar with a bond angle of around 120 degrees, and it has a 6 pi electrons, of which it is 3 pi bonds, which are delocalized in the p orbital itself. There is a cloud of the electrons above and below the plane of the benzene molecule. The pi electrons are closely held than in the sigma electrons and are available for starting the reaction. Benzene is electron rich, therefore susceptible to electrophilic reagents. So maybe next time, as we come to the end of our lesson, I want you to look at the benzenoid and non-benzenoid compounds, and then you look at how you can calculate whether the compound is aromatic, so that next time we shall find it very, very easy when we come and tackle that subtopic. Otherwise, thank you for attending my class. Unless there is any question, then, or any views or any critics, and then you can raise it now. And if there is none, then let us come to the end of our lesson. Thank you so much for attending.